So let's start with it. Hello, I'm Daniel López, full stack developer in Salsita, and today I want you to accompany me in my search for the perfect voting system. In case someone outside Salsita is watching this, we elect some employees to serve as part of an advisory body, which we call the Saucerers, when we have a Saucerer election coming soon, so I thought this would be an appropriate topic. Remember the last election? What if I told you that if we had used a different system, we'd have gotten different results? Probably you're not very surprised. What if I told you that the system we used has flaws? Was it unfair? Can we fix it? So if you want to know, I invite you to accompany me in this journey where we'll try to find the perfect voting system. So if we want to talk about voting systems, we should probably start with what is a voting system. You can imagine it as a set of rules that takes a set of candidate options and a set of votes and decides on a winner or a set of winners. And I'm showing you this because it makes it easy to see one of the points of the presentation, which is that obviously the winner depends on all the other elements. Like the winner must be one of the candidates, and the rules will interpret who is the winner based on the votes. But also, the votes depend on the other elements as well. Obviously, you can only vote for an existing candidate, and how you vote will depend on what you think about the candidates. And somebody said something. Should I stop and... Okay.
No.
Nope. Sorry. Okay. So how you vote will depend on what candidates there are and what you think about them and so on. But it also will depend on the rules. First, because the rules will tell you what form your vote will take. Like, will you choose a single candidate? Will you rank all candidates according to preference? Will you score all candidates from 1 to 5 stars? All of these are real examples used in some voting systems. But also in some cases, if the rules are not particularly good at allowing you to express your preferences or at translating those preferences into your preferred winner, it might be that your best option is to vote tactically, also called voting dishonestly, in order to get a more preferred result. And this is bad, of course, and a good voting system will minimize that. But yeah, that's just another example in which the voting system can affect how people vote. We'll talk about that a bit more later. So why do we need a voting system? Well, sometimes decisions need to be made. Let's imagine we're considering changing the color of the Salsita logo because someone said it would look better in green. It was something about simplifying the color palette or showing that we care about the environment or some whatever. So now we have two options. And now it looks like it says SS, which it does. So let's quickly move on before anyone notices. But I mean, actually, it's not that bad. It could be worse, I guess. Anyway, yeah, we have two options. As mentioned, you might wonder how these options were reached. Why green and not purple? And yeah, that's a great question. And that can be even more important than the final decision. But this is a bit off topic for the current presentation. So two options, green and red. How do we decide between them? One of the systems that's been historically most widely used is what Terry Pratchett would call one man, one vote. This is when there is a single person deciding, one man or woman or whatever. So there is only one vote, and that's the one vote that the person casts. So essentially, this person just makes a decision, and that's it. That is actually really simple, and it's surprisingly effective. As long as the person can make up his mind, like, you're guaranteed to get unanimity in any vote. And okay, you might think I'm joking, which I am. But if you think about it, this system needs to be there for some decisions. Like, you cannot just consult everything with everyone who might be affected like all the time. It's a waste of time for like some of the issues. You would just not get anything done all day. But you know, some decisions have high enough impact that we might want to ask for people's opinion. Now, that starts getting a bit more complicated because it often happens that different people have different opinions. So let's suppose for simplicity, there's 9 people in Salsita whose opinion on the logo color matters, mostly because I don't want to draw 80 people. So what do we ask them? As I said, the most obvious question is probably, what color do you prefer for the Salsita logo? And the possible answers are red or green. But even if in this case, which is the simplest of cases where there are only 2 options, there are other things we could ask. We could ask them to rate both colors from 1 to 10, or choose all colors they approve of, which would give them 4 combinations, either red or green or both or none, and so on and so forth. And as what we ask will affect how people vote and the result. But for now, let's just ask them to choose their favorite color. Let's suppose 4 people vote red, 5 vote green. Green wins. We have a new logo. Everyone's happy, or at least the majority. So I mean, since the opinion was divided and we cannot have 2 logos really, changing the logo to green in this case is not only fair, but it's the best decision we can take given the question we asked and the results we got. So, okay, now let's complicate it a bit. Suppose someone thinks the logo should be yellow because reasons. And fun fact, I was dry running this presentation with Simcha, and her husband, who designed the logo, saw this on her screen and was wondering what the hell we are doing to his logo. But yeah, we had to calm him down and tell him that we're not really seriously considering that. So yeah, now we have three options. We'd have to repeat the election, of course, but let's keep the same system. We're asking people what color they like best. And suppose it now goes like this: 4 red to yellow, 3 green. So now the traditionalist, red pepper, left-wing party wins. And it's left-wing because they're on the left on the slide. And again, it seems fair. But how well does that represent what people actually want? Well, we don't really know, I would say, because this system, which, by the way, it's called plurality, also known as first past the post. So this system only asks what each person's favorite color is. If people only care that their favorite color wins and they don't care at all about the other colors, then this is a good question to ask. And this is a good voting system, and the result is fair. But imagine what if people were not unidimensional? Maybe both the yellow and green pepperers are tired of the traditional red logo and they really want a change, and they would prefer anything before red. So in the initial case, with only red and green options, the 5 non-traditionalists were happy with the green logo, but once yellow was introduced, this caused their vote to split, and it gave the victory to an option they preferred less. Spoiler alert, this is called the spoiler effect, and this is one of the dozens of issues that voting systems can have. The spoiler effect happens when in a voting system, having 2 similar candidates hurts them both, as we saw in this example. So no, not all voting systems suffer from that, and I would say it's quite a bad thing because it makes candidate selection a lot more important than the actual election, and it can encourage people to vote tactically. And besides the spoiler effect, plurality has other flaws. Let's see a real-life example. Yeah, I went there. The US presidential election. Last one happened just a few months ago. It was widely followed around the world, so I'm sure you could tell me who were the candidates. There was Trump and Biden, right? Well, yeah, but there were a few more. Why did nobody talk about any of them? Well, to put it simply, the other candidates had no chance at all. Like in this system, they might as well not exist. The US presidential election is basically plurality, with some per-state electoral college complications to make it even worse. But let's not focus on that. So everyone knew that either Biden or Trump would win. Imagine a voter really like Rocky de la Fuente from the Alliance Party. Well, nobody cares. If that voter had a preference between Biden and Trump, they should have voted for either Biden or Trump. Otherwise, their vote was wasted. So this system requires voting dishonestly in order to have your vote even count at all. So this is, I would say, a bad system. We should really strive for a voting system where the optimal voting strategy is to honestly state your preferences. And yes, the US system is a bit extreme example. And in all systems, there is some tactical voting you can do, but a good system minimizes that. Or at the very least, it doesn't require, tactical voting for your vote to count at all. As a curiosity, how would this have worked in Salsita? I added an asterisk here on the top because we didn't ask people to choose a single candidate. We asked them to choose 3, but we can extrapolate the first choice reasonably well. So we'll ignore everyone's second and third choices, and we would get Tomasz, Weiss, Eva, and Janko. Of course, if people knew this was the system, they might have voted differently. I know I would. And probably votes would be even more concentrated on the top candidates because people would not want to waste their vote on candidates who were perceived to have low chances. And just to compare the results for the real election with single transferable vote. So yeah, it would have changed things. So yeah, which as I said, it would be bad to encourage people to vote dishonestly in order to fulfill their goals. So congratulations, Salsita, the system we used is better than plurality. So yeah, summarizing, plurality has a few pros, which is it's a very simple system to understand. It's good, but it's also quite bad if there are more than 2 options. I'm talking about it mostly to illustrate what we don't want in a voting system. So to analyze a voting system, we need to look at its consequences. Like, first of all, what does it ask the voters? For plurality, the question is, what is your first preference? And what does it do with that? Well, I should choose a different word. Plurality chooses the candidate which most people support as a first preference. And as mentioned, if that's the only thing they really care about, plurality ensures that the winner will be the one with the most support. But yeah, this is not how people think. In most cases, people will have a preference between other options. Also, if there are more than 2 candidates, it doesn't necessarily represent a majority at all. Like if you had, imagine, 11 candidates, a candidate would have 10% of the vote, and all the others could have 9%, and the 10% candidate would win, which is quite a low support. And there's also the spoiler effect, as mentioned before, where having 2 similar candidates hurts them both because it splits the vote. And all of this promotes tactical voting because people that prefer less popular candidates know that voting honestly is less likely to give them what they want, and it might be completely useless. So we can start creating a list of features that we want from a system from what we just learned. So we would like to, to allow voters to express their true preferences. We've seen that in plurality, expressing a preference about only one candidate doesn't seem to be enough. Just saying A is the best is too simplistic. We also don't want to encourage tactical voting. We want to encourage people to vote honestly, not to think about who has better chances to win and who doesn't, and try to game their vote to make it count. And in particular, we don't want the system to favor some candidates over others in any way. This is related to tactical voting, but it merits its own point. As we saw, plurality encourages you to vote for popular candidates, so it favors them. But, well, popular candidates will already win by their own merits, so we don't want the system to be even more biased in their favor. Also, plurality is actually very simple to understand, as we said. So, I mean, this comes at the cost of all the other points above. So, I mean, in a system, we can accept a bit more complexity to fix all these issues, but we don't want to end up with a system that's too complicated for the voters to understand. So let's score plurality. It sucks at representing people's preferences. It strongly encourages tactical voting in favor of, one of the 2 most popular candidates. So yeah, after seeing it, we've learned it sucks in some particular areas, and now we can use it as a bad example. So how can we improve it? What if, instead of asking people only about their first preference, we ask them to state all their preferences in order? This would solve the first point at least. Following the previous example with the Salsita logo color, it could look something like this. This looks a bit like traffic lights, but that's a clear way to represent it. These 4 people prefer red, and then green, and then yellow. These 2 people prefer yellow, then green, and then red. And these 3 people prefer green, then yellow, then red. Great, we just solved it. I mean, at least we improved the first point significantly. Now we can state preferences more expressively, so we're in a much better situation. Except, yeah, well, who won? How do we decide that? There's no real obvious way to do it. And as you might know, when voters express their preferences in order like this, that's called ranked voting, and there are multiple systems, like lots of systems really, to determine the winner or winners. And of course, if there are different systems, that means they can give different results. Let's not beat around the bush, and let's start with the one that we use in the Saucerer election, or simple version of it. This was Single Transferable Vote. In the system, we look at the top choice of all votes, figure out which candidate has the least, and eliminate him until we have only one candidate. So in this case, yellow has the least votes. We eliminate him. And we get a comparison between red and green. And in this case, red has 4 votes, green has 5, so green wins. Sounds actually good. It makes sense. It doesn't seem to really promote tactical voting, because if you prefer green to red, you should rank green higher. Except, well, let's see another example. For this example, I need bigger numbers, so I don't want to draw 15 votes. It's going to be harder to follow. So I will add a number on the top of each vote to represent how many people chose the permutation. So 6 people voted red, then yellow, then green, and 4 people voted yellow, green, red, and so on. Let's do it quickly. First round, red and yellow have 6 first preference votes. Green has 5, so green is eliminated. Second round, 11 red, 6 yellow, red wins. But now suppose that in a parallel universe, the red supporters made a better campaign and ended up convincing these 2 people that red is better than yellow. So that would move these two votes from yellow, red, green to red, yellow, green. So it would look like this. Now, since red was already winning on the first case, and now it just gained more support, you would expect that would cause them to win even more. But you'd be wrong. Let's count it. First round, now yellow is eliminated first, because it has 4 compared to 5 green and 8 red. Second round, we have 8 red votes and 9 green votes. So green wins. So making a candidate more popular can make them lose. That doesn't sound great, but you might ask, how often does this happen? It's hard to answer using real data because few governments use this method and they don't release the full data to the public. But according to some mathematical models, it could happen up to 14.5% of times, which is quite a lot, I would say. And to be fair, this is not something that can be predicted or controlled or manipulated. You would really need to have really accurate information about the votes beforehand. So I don't see it as necessarily a huge problem, but it's there. Also, to be fairer, there are dozens of features that you might want to have in your voting system. Let's take a look. This is a table, and each row represents a ranked voting system, like where people rank candidates in order of preference. You don't have to look at all the detail, just see the color is enough. And each column represents a desirable property, and all systems failing one or another. So, like for example, we have, I don't know if we have, it's difficult to see, whatever, doesn't matter. Yeah, instant runoff voting is the equivalent to single transferable vote. So it fails on 1, on 5, 6, 7 of these things. So there are, for example, systems that don't have a polynomial time algorithm that computes the results. There are systems that are not guaranteed to elect a candidate even if the majority of people rank him first. There are systems that we've just seen where increasing someone's ranking can cause them to lose, and so on and so forth. There are even mathematical proofs that you cannot have a system that satisfies certain subsets of these criteria at once. If you heard about Arrow's impossibility theorem, that's one of them. And if you expected me to talk about it, well, I won't, because I think it's not really that interesting. The criteria are not so applicable to the practical cases. But if you want, feel free to Google Arrow's impossibility theorem, and you will find it explained. There's very nice videos and so on. So yeah, the thing is that most of these criteria are, they are nice to have, but they can be very strict. And any reasonable system that breaks some of these criteria, they don't break them that much in practice. And if they do, it's in favor of some sensible candidate, not just because they did something really stupid. So I would say let's not really look at the artificial examples where systems might fail some criterion. I showed you one because it was interesting. But let's focus more on how systems allow voters to express the preferences and how they calculate the results from that, so we can see how they actually tend to behave. For example, in my opinion, a bigger problem about single transferable vote is the deeper structural issue in the system. It tends to disfavor consensus candidates. In this case, we have like 6 or 7 candidates, and green is everyone's second choice. And I assume that the full ballot is there, like that's a lot of the decisions. And all the others are very divisive. There is not real consensus of any other that is better than green. So yeah, green is the best consensus candidate, which is a good thing to have in many situations. It's also the first choice to be eliminated. Oops. So yeah, let's evaluate it. I think, single transferable vote represents voters' preferences better. I don't give it 5 stars because I'm not sure that voters have a clear ranking among all candidates, which would be required for this, but it's still a lot better than plurality. It also encourages honest voting. But again, it's not exactly perfect because you can always, if you prefer A, B, and C in this order, but you think C has no chance, you could vote for C ahead of B to give more chances to A. It's a lot more complicated and a lot lower impact than it would be in plurality. So there is that. Also, there is the issue where ranking someone higher can cause them to lose. But as I said, again, it's not something that affects how people vote because they cannot predict it. Also, it doesn't really give voters reasons to vote for more popular candidates unless they actually support them. But it can favor extreme candidates a bit, not the consensus ones. Overall, and again, it's like not that simple because it requires several steps to do that and eliminates a candidate, and it can take as much steps as candidates. So it's a bit more complicated. So overall, I think it's not bad. But, well, to be fair, this is not what we did in Salsita exactly. There were 3 relevant differences. The main difference, we were electing 3 Saucerers, not 1. Also, we were only allowed to select the top 3 ranked choices out of 10 candidates. And at last, if at any round any of the candidates got over 25% of the votes, they immediately won, and a small fraction of their votes went to each voter's next preference, which made things more complicated, and we will see it. So, well, you might think it makes sense, right? 3 winners, so 3 choices. Someone even said that in the first Saucerer meeting. Well, no, this is very wrong. Under this system, there is no relation between the number of candidates who are elected and the number of preferences you are expressing. Like, please think about your vote in the past election. If you think your individual vote contributed in the election of the 3 Saucerers, think again. Each vote contributed towards a single candidate. This is why it's called Single Transferable Vote. You have 1 vote that will be transferred between your candidates during the rounds. And as the higher candidates get eliminated, it will go to the lower candidates. I can show it to you. Here it is. So for example, here, let's look at, where is it? This vote. So this vote is going for Craig now. We're in the round 5 or whatever, eliminated half of the people already. So once we move to the next phase, we see that Craig is the last. So Craig will be eliminated. Craig is eliminated. Now this vote goes for Jirka. And if you move to the last phase, you will see, this vote counted for Janko. This vote didn't count for anyone at all in the end. This vote counted for Eva, but 0.105% of it also went to Janko. That's why he had 19.632 in the end. This vote went for Janko, not Eva at all. She was already elected at this point. This one was for Jirka, and so on and so forth. So what voters are expressing through this system is, I want A to win, but if A gets eliminated, and only if A gets eliminated, I want B to win. And if B is eliminated, and only then, I want C to win. And if they are all eliminated, my vote will not count for anything. So your lower preferences do not matter unless the higher ones get eliminated. Of course, they do matter at the time because they are deciding who is getting eliminated. But in the end, your vote will count for only a single person. Or if you voted for one of the candidates that got elected, a very small fraction of your vote also went to the next candidate on the list, assuming that the next candidate on the list was not eliminated by then. So this is not necessarily bad, I think, but I think it's not probably what people would have liked to express. Also, since your vote only contributes to one candidate, there is no reason to allow exactly 3 preferences in the list just because there will be 3 winners. We could allow voters to choose 2 candidates or 5 or 10, and the system would work. And there's actually good reasons to allow expressing a longer list of preferences. Limiting the selection to 3 options strongly encourages tactical voting. That's because if you want your vote to matter, you cannot just express your true preferences. You have to consider which candidates have chances to win and include them in your vote, or at least one of them, but preferably 2 or 3, just in case you're wrong about the results. And looking at the data, there were 8 people who didn't vote for any of the 3 winning candidates at all. That's 8 out of 66 votes. That's 12% of the voters that were completely ignored by the system because it only allowed 3 preferences, and these voters happened not to choose any of the top 3 candidates. And given how close the results were at the top, 8 votes could have easily made a difference. So this system discourages voting for less popular candidates because your vote is unlikely to be of use. And I dare say that this is not what we want in Salsita. The most popular candidates, again, are already more likely to win anyway without the system favoring them. Also, the fact that having 25% of the votes during any round causes you to win immediately really favors very divisive candidates. As a candidate, you don't need to get many people's support. You just need 1/4 of the voters to rate you highly. The rest you don't even need to care about at all. So the best strategy for a candidate that only really wanted to win is not to convince a majority, but to very strongly convince a minority. So overall, I would say it's still much better than plurality, but it has some issues. Like, it doesn't represent preferences that well, because people might care about more than 3 candidates. Also, they might want their vote to count for more than a single candidate, not only the first one that was not eliminated. It no longer encourages honest voting so much, because voting honestly might make your vote worthless, and now it favors for more popular candidates more. Also, adding this 25% rule, which causes fractions of votes to be applied to further candidates, makes it a bit more complex and harder to understand. Which is not a big problem, but I don't think it had much of an advantage in this case. So I really don't think it's a great system. I'm not saying it's horrible or that the election was not fair or anything like that. I think it was fair. The system was known by the voters. It allowed them to express their preferences in a reasonable way, and it came up with a good result based on that. But I'm just saying that it has some issues that could be improved on. So what are some other interesting ranked voting systems we could learn from? One of them would be Condorcet, named after the man who originally proposed it, Le Marquis de Condorcet, who in turn was named after the town where his family lived, Condorcet. So he said, comparing 2 candidates is easy. And since all voters gave us their full rankings, we have all the information we need to compare all of them by pairs. So if there is any candidate that wins all one-to-one comparisons with all other candidates, it would be very fair to declare this candidate the winner. It will be clear with an example. Let's have the same votes as before. We're going to compare red versus green. Just to make it clearer, I will remove the yellow. So 4 people prefer red to green, 5 people prefer green to red. Green wins against red. Then comparing yellow to green, 2 people prefer yellow, 7 people prefer green. Green wins. And let's compare red to yellow for completeness. 5 prefer yellow for red. So yellow wins against red. That gives us a fully ranked ordering. Green is preferred to both yellow and yellow is preferred to red. Amazing, we got this. Green is the winner. There is only a problem in which sometimes, let's just do a small change here. The guy in the middle decided that he still likes yellow the most, but now he prefers red to green. Okay, so let's do it quickly this time. Red versus green, red wins. Red versus yellow, yellow wins. Yellow versus green, green wins. So for those of you following at home, it would look like this. In other words, there is no candidate that is preferred to both of the others. Each of them wins against one, but loses against the other. And here is where you might ask, Marquis de Condorcet, qu'est-ce que c'est cette merde? Which for those who don't speak French translates as something like, Marquis de Condorcet, how do you propose we solve this situation? And his answer is something like this. No real answer. If that happens, this method just won't work. Actually, for this reason, this is not really a voting system. It's a criterion. It was in the columns on the previous slide where I showed all the Wikipedia table. It was not a system. It was a criterion that systems can follow. And there are systems which guarantee that if there is a Condorcet winner, it will be elected. So we could use one of those. But let's first look at how this would have performed in the Saucerer election. Well, again, there's an asterisk here. We don't know exactly because we didn't ask for the full ranking of preferences, but we can still do an approximation. This is a table that represents all pairwise results. So if you want to compare, let's say, Craig and I, you check these two rows. 5 people preferred me to Craig, 19 people prefer Craig to me, so Craig would win in this comparison. To make it easier, it's color-coded. So if the person in the rows wins against the person in the columns, that's green. If the rows lose against the columns, it's red. And if they tie, it's blue. And yeah, you can tie. It happened. 19 people preferred Tomasz Weiss to Craig, and 19 people preferred Craig to Tomasz Weiss. Interesting. Most interestingly, the result we had was acyclic. So we could establish a full ranking. Any candidate in this list that we have here beats all the candidates below in a pairwise comparison. And the numbers here show the comparison only between adjacent candidates. So Eva beat Janko 26 to 23, but also she beat all the others. Janko beat Jirka 25 to 21, and he beat all the others, and so on. So interestingly, this does change the result of the election. because we didn't know it, but we were electing 4 candidates since Karel took an absence. So the 4th candidate, according to our system, was Tomasz Weiss, but Condorcet would say that Pavel Przybyl should be there, since 19 people prefer him to Tomasz, and only 18 people prefer Tomasz to him. Yeah, the results were really close. I don't think you could say this was very unfair to change this. So yeah, how do we evaluate Condorcet? So in the system, voters' preferences are well represented, assuming they can come up with a full ranking of candidates again. It also really encourages honest voting. If you prefer A to B, you should rank A higher. There is really no good way to vote tactically. But it's quite complex, because it performs pairwise comparisons between all candidates. Also, it might not give you results, so then we would have to find a system that does satisfy the Condorcet criterion, and then this system would have its own features. We'd have to evaluate that. But what if we assign a numerical value to each position in order? So it would look like this. So this is called board account. We would assign 2 for the top choice, 1 for the second choice, and 0 for the third, or any other decreasing numbers. So we would add them together and get 12 points for green, 8 points for red, 7 points for yellow. Green wins. This is called board account, as I said, and it's a system that you might be familiar with from Eurovision. In Eurovision, people or countries actually rank other countries, and the top choice gets 12 points, the second gets 10, and so on and so forth, as you can see in this list. Let's see how this would have performed in Salsita. So these are the results for those of you who are curious. I gave 3 points to the top candidate, 2 to the second, 1 to the third. And again, I have the asterisk here on the top. But here it's a big one, because having 4 rankings would have drastically changed the amount of total points, and thus possibly the results. And yeah, with the information we have, it would have given us the same results of the top candidates in the official election. So again, voters' preferences are well represented, assuming they can come up with a full ranking of candidates. It encourages honest voting. You can express your vote honestly, and it will be counted fairly. But it's also a bit easy to manipulate, because if you think only A and B have good chances, and you prefer A, you might want to rank B last. So A has better chances against B, even if you like B more than some other candidates. And that would penalize B quite a lot. It also doesn't particularly favor any candidates, and it's quite simple. Each vote represents a number, and in the end, they just add it up together. That's a very simple calculation to get. But having reached this point, I would wonder, how do people's preferences actually look like? Why am I giving 4 stars to these systems on the first criterion all the time? What would 5 stars look like? I talked to a very small number of people, like really small, like 3 people, so it's not statistically significant in Salsita. But I asked them what they thought about the Saucerer candidates from the inaugural election. How do you think they express their preferences? How would you express your preferences about the candidates? Would you say, I like candidate A and I don't care at all about any of the others, as you would vote in a plurality system? Or maybe you would say, my favorite candidate is A, and after that it goes B, and then C, and then D, as you would go in a ranked system. Or maybe you would say something like, I like candidates A and B a lot, C and D are good, and I don't have a strong opinion on E, but I really dislike F. And hey, even if you really dislike F, please respect for F. But yeah, so the people I talked to, and myself as well, I would include myself in the list, express their preferences in a way that's most similar to the last option. People obviously have opinions about more than one candidate, but they really don't have a clear ranking. They cluster candidates together. There are candidates they know well, in which case they have a more defined and stronger opinions about them, like either very good or very bad, or sometimes in the middle, but there's more information. There are candidates they don't really know well because they haven't worked closely with them, so it's a bigger unknown. So if you represent this by strict ordering, you are forcing the voter to add a relation that might not exist in their mind. So in this list, A and B are equal. The voter has no preference about them. So if you force them to express a preference, you're adding something that might not exist. And you're also not really capturing that A and C are close, or A and B and C and D are pretty close. A lot is quite close to good, I would say. But E and F are quite far. Like no strong opinion is very far from I really dislike somebody. Also, you do not allow no preference vote or like blank vote for a specific candidate, if you want to call it like that. If the voter doesn't know the candidate well enough, they might want to just not express anything about them and let the other voters' opinion count on that. So allow me to add two nice to have criteria for the election. We would like to be able to mark two candidates as equal, also express no preference for some candidates, without, of course, that no preference counting as the worst possible rating one can give. That's what we had in the real election. Like the top three candidates were the top ones, and there was no difference between I don't care and I hate this person like with my whole heart and soul. So yeah, in these previous systems we explored, this wasn't really an option. One way that partially solves this is a rank system that allows equality. So the preference from before would be better represented by this ranking, where A is equal to B and C is equal to D. And there are ranked voting systems that allow for this. And this solves the first issue. A and B are now equal in the voter's mind and in the vote. But the big difference between E and F is not captured, which might or might not be important. And it also doesn't solve the no preference issue. So I have another suggestion that solves all of this, and I think will feel more natural to you. And I've even been foreshadowing it during this presentation. You might guess what it is. It looks something like this. Just give a rating to each candidate. This allows more expressivity than the previous system, because now the difference between E and F can be 2 stars. And if you don't assign a value to a given candidate, it's not a big deal. Like the system can handle that correctly. They can just not count it for the, basically you can just calculate the mean of all the values, and this value would not be included. And this is also something we're really used to doing and seeing everywhere. Like you rate apps on your phone from 1 to 5 stars. You rate purchases in Amazon, your Uber driver, your Airbnb. You rate brown bags as well. I rated the features of voting systems in this scale during this whole presentation, and I'm pretty sure you understood them. You didn't have to wonder what this thing means. And I think it was even more intuitive than if I had ranked the voting systems in each of the criteria. So it feels really natural, I think, and everyone has a good idea of what each star rating means, or what each star rating they could give to a given candidate. So yeah, if we do that, we're moving to a different kind of voting. It's called cardinal voting. In cardinal voting, you don't rank all candidates in order of preference, but just assign a number to each of them. Even then, the question is, what numbers to allow. A very natural one, as I mentioned, would be to rate each candidate from 1 to 5 stars. You can call that score voting. Simpler one is just 0 to 1. It's called approval voting. You give 1 to anyone you approve of, 0 otherwise. Another one is -1 or 0 or 1, which is the same as approval voting, but you can penalize people you really disapprove of. And then you can add up the numbers for everybody. And the highest one is the winner. Or if you allow the voters to give a blank vote to some candidates, then the one with the highest mean is the winner. And I think this is much simpler for the voter. They don't have to sort all candidates or do any direct comparison between candidates. They just need to individually evaluate each candidate and give it a rating from 1 to 5 or from 0 to 1 or whatever. They don't have to make decisions between 2 similar candidates. Just for completeness, an example. Each person chooses whatever number they want for each candidate. We add them up. So total is 12 reds, 15 red, 13 yellow, green, 14 yellow. And you might notice maybe that this can favor middling candidates. Nobody really likes red very much. Like there's a 4, but it's nobody's favorite candidate. But it seems to be the best compromise because the others are kind of not a bit disliked by more people. So yeah, we're getting the best compromise candidate. And that's actually a good feature in most real-world elections, I would say. You'd rather have that than a candidate that most people love and a lot of people hate. But in some cases, you might not want that. For example, I think in the Salsita case, that's a personal opinion here. Like I don't know how everyone else feels, but I think I'd rather have a few Saucerers that I really like and a few that I really dislike rather than having all of them be like meh, some middling candidates, because I think this would spark better debate and it would have, like, it would be more interesting than more than just everyone agreeing on everything. And of course, in the system, we can change that if we want to. Instead of offering options 1, 2, 3, 4, 5, we could use, for example, Fibonacci progression. So we would offer people options 1, 2, 3, 5, 8. So the person you like the most would get 8 points. And this would favor candidates with more extreme voters, because the higher votes disproportionately favor that. So with the same example, we would map 5 to 8 and 4 to 5. And we would have this. I highlighted the numbers that changed only. So more controversial candidates, which are the ones that have more extreme scores, benefited from that because the system favors them. So now yellow wins. This does make it, I don't know, more complex, a bit less natural, because people are not really used to ranking things from 1 to 8, 1, 2, 3, 5, or 8. But I mean, if we really want to do it, if we really care that we want to have more extreme candidates, we can. So let's score voting. I think the system represents best the voter preferences in Salsita, at least. It's a very natural way to rate the options, and it can allow ties and blank votes, which I think is necessary for our case, or it's at least useful. It encourages honest voting, but again, it allows you to vote tactically if you want. If you really want candidate A to win, you can give him the maximum rating and the minimum rating to all the others. But I mean, if you want to vote like that, I would say the system is perfectly capturing your preferences. You just happen to have very extreme preferences. Also, it doesn't really favor any candidates. It can be tweaked to slightly favor consensus candidates or extreme candidates, if depending on what we want the system to encourage, if anything. So, and yeah, it's quite simple, like it's quite intuitive. It's not as simple as plurality, because you have to rank all the candidates or most of the candidates, or at least all the candidates you care about. But I think it's pretty intuitive and pretty simple. And it's very simple to understand how you got from the votes to the winners. And now I want to show you as well. There's actually some comparison between systems that's based on some simulations that were run. Unfortunately, it's for the single winner case, but it should extrapolate well enough, I think. So here, the x-axis, it represents the group's overall satisfaction. So the more to the right, the more satisfied people are with the winner. And the y-axis represents how simple a system is. So the higher, the simpler. Simple system is to choose an election at random, but yeah, that's not very satisfactory, I would say, or even according to the simulation. And each blue bar represents a system. The left edge of the bar is the satisfaction if all voters vote tactically. It's called strategically here. And the right side is what happens if all voters vote honestly. And each blue bar represents a system, of course. And yeah, so if we can check that, we see that score voting is the best if most voters vote honestly. If all voters, or even most, yeah, vote honestly. And it's still also very good if everyone votes tactically. Like, it's as good as approval rating if in this extreme case, and it's better than any others. Interestingly as well, single transferable vote is as bad as plurality voting if everyone votes tactically, and is considered, I would say, I agree that it's more complex. So one of the lessons that we get from this, apart from the ranking of which voting systems might be, might give better group satisfaction, is, hey, vote honestly. If everyone votes honestly, everyone will be more satisfied in general. So this now will get a bit meta. So if we had a vote regarding which voting system to use, supposing we agreed on which voting system to use for that vote, this would be my vote expressed in a 1 to 5 ranking. I think score voting, where you rank candidates from 1 to 5, allowing blanks if someone doesn't feel like they have enough information, is the most suited for the Saucerer election for all the reasons I just mentioned. Otherwise, approval voting, where you rank candidates with 0 or 1, it's simpler and it could also work well. board account where you just rank all the candidates and the top ones get higher numbers, but you don't get to choose the number exactly, or you just choose the ranking, is also like quite reasonable. I have no preference on Condorcet because we'd have to agree on a specific system that fulfills the criterion and guarantees a result, and then we would get into more. Well, we don't have enough information basically to choose on that. Single transferable vote is not bad, but I don't like that it only counts your vote for one candidate. Single transferable vote with only 3 ranks for 10 candidates promotes too much tactical voting, in my opinion. Plurality just sucks, and one person, one vote is the worst. So the conclusion after our search is that, okay, there is no perfect voting system. That's something that you might have expected. So if you were expecting me to find the perfect voting system that solves all our problems, I'm very sorry to disappoint you. But I think there are systems that suit our purposes better than the one we used last time. So I want to make a call to all Saucerers, and of course to Matt, the man with the vote, the Uber Saucerer, the Saucerest of them all. I would like you all to think about this and consider changing the voting system for the upcoming election. We're still on time. Most of the ones I mentioned would be better, in my opinion. I will add a ticket to the agenda with some summary so that you can discuss it on the next meeting. And with that, I thank you. But wait, yeah, last thing. Maybe I would also like you to consider changing the Salsita logo to green. I heard it's very popular. Now, any questions?